Alright, so what we're going to be doing is we're going to be putting 2 holes in this plate. We're going to use 2-inch holes, and to increase the strength of this thin 16 gauge material, which is .063, we're going to be using a dimple die, custom made, 2-inch, to give us a dimple on the outer rim of the circle to increase the strength and rigidity of this 16 gauge material. Right? What we're going to be using is a hole saw, a generic hole saw, which uses a pilot bit, and then the hole saw gives us a nice OD hole of 2 inches. We're going to put 2 of them in there. We're going to use a drill press to do that, and then we're going to use a press to press our dimple die. Okay, so what we're going to do is we're going to place our holes, the center of our hole, 2 inches in from the outside edge. We're going to put our second hole 2 inches in from the outside edge, which should leave us about a 7/8 gap in between the 2 2-inch holes, which should give us enough room to put the dimple in there. Okay, so I'll quickly mark these out. Okay, so we got our center points marked where we want to use our center punch. Okay, and if you don't like where your center punch is, you're able to move the center punch around a bit by angling your center punch into the direction you want, and you're able to shift your center point. So you don't hammer it too hard on your first initial blow. You're able to check where your center punched it, and these are off, so I move it over, and now I like where it is, so I can go with a harder center punch. Okay, so to drill our holes in our 16 gauge sheet metal, we're going to use a little tabletop drill press, which may be going a little quick for this application. The slowest speed obtainable on this drill press is 620 RPM. Alright, that'll be okay, but what we'll do is we'll just keep our downward pressure to a minimum, or see how everything's acting when we're drilling. Make sure it's tight, centered. So when drilling on a drill press, you have 2 options. One is you can clamp your workpiece to the table, or 2, you can have the workpiece right up against the pillar, immobilizing it from spinning once you start. So you want to roughly line up your pilot hole. Start your drill press. So I forgot to put something to drill into, so I stopped and I got a piece of plywood to put under my piece. I've clamped it to my table, secured my table, and now we'll try that cut, which, like I said, does seem like it's going a little quick for this material. Done. One done. We switched to the hand drill because, like I said, that drill press has too high an RPM. It was creating a lot of chatter. It just was not making for a comfortable cut. So we'll just flip our little piece around. trouble lining up the hole. As you can see, the lights don't shine underneath the 2-inch hole saw, so it makes it difficult. Alright, second one's done. Okay, so we put some gloves on because now this it's sheet metal, it's going to be a little sharp. Try and keep all the filings on the bench. Got a little distortion in our piece from cutting, and we have a nice sharp burr that we're going to have to take out. This is a deburr tool, so hopefully it's going to remove some of it, and it doesn't look like it's going to do a good enough job. So we're going to switch to possibly a die grinder. Possibly just a big flat. We'll clean up our area here. The deburr tool wasn't strong enough to burr on the metal, was a little heavy duty there. So what we're going to do is we're going to use a die grinder. When you use your air tools, always want to make sure that you oil them before use. This will ensure that they last a long time. And we'll take that burr off. Okay, so we have our dimple die here with our chamfer. It fits nicely onto it. What we're going to do is line this up in the press. We're going to take our dimple die, put the top on it, press it down to give us the dimple. Now we do notice that we only have a small amount here, so the dimples may run into each other. But this is for demonstration purposes, and then when we make our piece, we'll know how close we can put them together. Okay, so we have our dimple die set under our press on a big piece of steel that's going to take the tonnage. Our dimple die fits nicely over it. We put our die on top. We're going to use our block to bring it up to the press height. And it's an air over hydraulic press, so we're just going to hit the air, and here we go. Okay, we just got contact there. You see it's starting to bow. Okay, when the piece levels out, we're right at the pressure that we want to see for the dimple effect. Not going to raise the press up too much, as I had to bring it down quite a bit. And we'll take out our blocking, take off our die top, and we have our first dimple. So I think that they're close enough that we're going to be able to get two. So I don't know if you can see that clearly, but we have a nice dimpled radius around the edge, giving it tremendous more support. So this side here I can bend, and this side here has become a lot more rigid with this downward force. So what I'm going to do is, I think the compressor is a little low on the pressure for the ram. I'm going to go crank it up, and we'll do our next one. Okay, so we have our first initial dimple die, nice close to the edges. So now when we do make our components, we'll know how much of a radius we need to leave for the dimple. It does look like will be enough spacing to get the second dimple in. We'll just verify that. We'll see if the compressor can keep up. I've increased the pressure, got it in there. We'll put our blocking in there now. And we'll see how everything carries on. So we were successful in our second dimple die. It looks like we still had some room to spare. So when you're making a component, you can know how close you want them or how far apart you want them. But this piece right here is extremely rigid for just having about a 3/8 edge, 1/16 thick material. I'm unable just to twist that with my hand. If I were to have a compromisable piece of steel, I can easily bend this. Right, and that's over 1/2 inch. And then once you put the dimple die in the piece, extremely rigid, giving you a lot more support for your off-road applications or whatever type of build that we're doing. And what we're going to do now is make up a similar piece. We'll drill 2 holes in it, and we'll show you how easily that we can bend the one without the dimple dies. Okay, so what we're going to use to cut us another piece of material is we're going to try out this 14 gauge handheld electric shear. It's a power fist, so it's one of the more affordable models up here in Northern America. We're going to lay our piece out. We're going to use a piece of silver streak marking pencil. It's good for metal. Okay, see this is a nice clean line, and we'll see how this thing shears this up. I'm pretty happy with the way that performed. We do have a little bit of deformation on one side more than the other, but that's very common with these type of shears as one side gets deformed as it gets pushed down. So what we usually do is use our little hammer, give it a couple taps, and we get ourselves kind of straight. So what we're going to do is we're going to use the same material, same thickness, 16 gauge. We're going to drill 2 holes in it, and we're going to do a twist test to see the integrity of the piece. So the increased integrity that's given to us by the dimple die effect. Okay, so we're going to punch us the new hole centers. We're just eyeballing these ones as it's just for a demonstration of the integrity of the material after the dimple die's been dimpled. Okay. Now we're going to go back to the hand drill on the piece of plywood, as it was a better speed for us than our drill press. voila, the first hole is done. The drill really likes to bite near the end, so you have to be careful so you don't... Be careful so you don't hurt your wrist or damage your hole saw when coming near the end of the cut. Okay, so we've now got our 2 holes in the 16 gauge material. No dimpling on the holes, and I'm able to bend this piece easy peasy like butter. Okay, it's a little harder to go in the twisting fashion, but like in the linear fashion it's extremely ductile. Now when we have the dimple die in there, I cannot easily bend this. Okay, so what we do is now we have a reduced weight with the same strength or increased strength to similar material of similar thickness. So I can still, with this one here, you can see me easily doing a short section, I'm able to flex it. Now it is strong, but there is no reduction in material or in weight. Now this one having a huge reduction, very like limiting sizes. If the outer skirt or the outer flange area was wider, it would be a lot more stiffer. And I got 3 or 4 times the stiffness of the regular material. So that's how you use a dimple die.